Here we go. I'm recording, so you guys have to be quiet from now on. All right. This is the problem I asked you to do yesterday, that everyone that was in class came home with the, or came back with it completely done. The answer was 1.035 of N2. It was 1.305 of NE, and it was 0.66 of, I don't know why I wrote that again, of CO2. All right, moving on. Partial pressure of water. Thank you. All right. When we do any type of gas collection, if it's done over water, we must realize that there's water vapor in the air. So to find only the pressure of the desired gas, one must subtract the vapor pressure of water from the total pressure. It's super easy. You just got to remember to do it. Well, that's partially. It doesn't account for all of it. And like I said yesterday, I'm not exactly sure why it's so far off. All right. So when one collects a gas over water, there is water vapor. The pressure due to the water vapor must be subtracted out before you calculate any PIV-NERT values. So if I want to know the volume, all right, it's nRT over P, and this would be the pressure of the gas I'm looking at, but not the pressure of the gas and the water vapor. So it's super not bad. Once again, you just have to remember that that's an extra step. You have to subtract it out before you do anything. So as soon as you're ready to go, we'll go. There is track today, Bennett. We all, not all, but a lot of us got our shots last night. It was very nice. It feels fine. Like, I mean, I wouldn't want someone to punch me right there.
That's what Bert said he was going to do.
But,
well, he said he was going to go around hitting
Bert can't because he's a wuss. He's the one in pain, not us.
like a communist right now or
No. No, it's fine. I do not feel, I don't feel that way.
Have you had any inclination?
All right. All right. Here we go. Here's what's nice about vapor pressure. Vapor pressure, please, it will always be given to you in a table or as part of the problem. It's super simple. If it's in a table, you need to know that vapor pressure and temperature are dependent. So all you would do is, if it said that it usually, that it happens at room temperature and room pressure, so we'd say, oh, that's 760 torr. We would use that for pressure. But we wouldn't really. If it's room temperature, it's 25 degrees. So before you do anything with pressure, you would subtract 23.8. And this would be the new pressure that you used, 736.2. Is that right? I don't care if it's wrong, but whatever. Yeah, well, the 1 ATM is equal to 760 torr. So room pressure is 1 atmosphere on top of my head. So yeah, that was a direct message, wasn't it, Judah? Judah asked me that last night. He said, does room temperature ever vary? In short, like at my house, the room temperature varies, but in science, when we say room temperature and pressure, we mean 25 Celsius and 1 ATM, despite how room, or the actual real temperature. Okay, so it's just one step, subtract whatever it is on the table from the given pressure first, and then just do PIV-NERT as normal. All right, so here's an example that's considered easy. 195, I don't know why I said 5, whatever, 193 milliliters of O2 was collected over water. Now, sorry, I'm still immature. These I can't even do it. No, just these. I'm 12. I'm sorry. These problems will always say something about being over water, or it will say, just it will say 193 milliliters of wet gas was collected. Now you know. If you know, you know. If, no, they'll just say 193 milliliters of wet oxygen gas. What wet gas means is it was collected over water. So you see why I'm 12. Because it is, it's got water in it. All right. It was collected on a day where the atmospheric pressure was 762, the temperature of the water was 23. How many grams of oxygen were collected? All right. To find grams, I really need to find what first? I'm kind of working backwards. I need to get moles. Because remember, there's no grams in PIV NERT, but there's moles, and moles and grams talk to each other, right? All right, so I need to solve for moles. If PV equals nRT, then N must be equal to? All right, so we just solve. But if it's collected over water or it is a wet gas, what must we do first? Subtract. So we take the given vapor pressure, 762, and we subtract the vapor pressure at 23 degrees, 21.07. All right, what's that? And this is your pressure. Then you just do the rest. I'll let you do the rest. So it's not complicated, but if you don't do it, you get it wrong, and it's kind of sad.
David said, I think you and me are more alike when you watch this game.
How come?
Like gas and stuff.
Okay. All right. Are we done? Okay. So you say it doesn't have to be. Your answer will be, oh, sorry, yes. You need to convert that to liters at the top. I thought you meant your answer. What? Oh, oh, that's scary. Only for water because it has a density of 1. So we use the molar mass of oxygen to figure out the grams once we solve for moles. Always. Oh man, what a blunder. How many of you did not divide by 760? Oh, Grace. All right. I will talk this through in a second. Did you do it? Did you do that? What's this number right here? Okay, times 32 is? Don't ever worry if you do these and they're small answers. They can be really small. Get it now, Walker? Okay. You good? Grace?
Wait, why do you multiply by 32? Oh, yep, got it.
All right. Let's talk it through. I definitely heard some grumblings in the force. Let's make sure that we're good. When we do chemistry, we really got to know what we're doing. We're being asked for grams, but we're given a volume of a gas. If we ever deal with a gas, we know we have to use Pivnert. Then we should know that grams and Pivnert don't talk to each other, but grams and moles, which come from Pivnert, do talk to each other. So I'm going to solve for moles, which is this answer right here. Then to find the ultimate answer, I'm going to multiply it by 32 because that's the moles per gram, or sorry, grams per mole for oxygen. Okay, so I need to solve Pivnert for N. That's where this came from. PV over RT. This was a wet gas, so I had to subtract out the water vapor. And so this was the pressure I would use in my problem. But right here, please remember the following. R needs things to be in Kelvin and liters. That says liters, just trust me. And ATMs. We have to have Kelvin, we have to have liters, we have to have atmospheres. So coming back here, this step right here, this was the conversion of torr to ATM. That must be done every time unless the problem gives you ATM. All right, then this piece right here, it had to be in liters. So the 193 milliliters turned into 0.193 liters. Then R is right here. Hopefully everyone had that part right. And then we have to have Kelvin. So this was 273 plus 23 or 296. Like there's all sorts of landmines because hopefully you've thought, wow, this math is pretty easy. But you got to remember to convert all the stuff before you put the puzzle together. All right, we do all this and we got 0.007 moles. And on the exam, kids will do this and they'll leave it. And that's sad. I love you, but you're dumb. All right, that's moles. It's asking you for grams. So the last step, once again, is to multiply by 32 and we get 0.248 grams. Okay, now that's not bad. Hopefully, this is an easy one. Oh, well, I was gonna do that anyway. This is an easy one. They get harder. You haven't even looked at it yet. So equal masses, and then it tells you 5 grams of each of oxygen and methane are placed in a 4-liter flask at 25 degrees Celsius. The mixture is allowed to react to completion and the flask is returned to 25 degrees and allowed to come to equilibrium. The vapor pressure of water at 25 degrees Celsius is 23.78 torr. So, give the balanced equation. What's the total pressure inside the flask before the reaction begins? What is the mass of the water vapor in the flask at equilibrium? I don't know why D is that way, but whatever. Which reactant is in excess and how many grams of it remain at equilibrium? Oh no. Chapter 4 again. I hate chapter 4. Okay, I don't, but you do. All right. Letter E. What is the total pressure of the flask at equilibrium? Bonus. After the reaction, is there any liquid water remaining in the flask? If so, how many grams? If not, then why? I love this question. I wrote this question. What time are we out of here? Hey. And you wonder why I like Cooper. What? Okay, 10 minutes. All right. Do you want to work on it on your own? All right, start it up. I'm Tom. Sorry. Yeah. We all love dad jokes when we mock people. You can be wet gas.
Davidson, see, this is why we make fun of Cooper.
No.
This is the reason.
I'm taking that.
I'm sure you could, David. You don't have to do the problem.
Yes, I do. I have to do it in front of people.
But you already you wrote the problem.
Yeah, but I haven't looked at this problem in a year.
Wait, how many years have you had this problem? Like,
Don't say it.
At least 5.
I'm not that old.
You're not 5 years old.
Nope. Okay, keep going. Shh, 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 shh. Keep going. Keep going.
Wait, should we just assume that it's room pressure?
Yeah.
So would we, or just subtract the 23.76 and then divide by 760? Yes.
Say it, yes, probably. That will be your.
You take 760 and then you subtract, and then divide by 760. So you don't have to do pivot to find the pressure before? No.
The pressure before? No, yes, you do. Sorry, so your first question, I should have been reading when I asked. No, you don't.
So, wait.
You're solving for pressure in this problem.
Yeah. So when do we account for the vapor pressure at the end?
It's in there. twice it's got his meaty hooks. You'll see.
Wait, so we don't.
So we don't.
We don't subtract 760 by it.
Yeah, 'cause
We have
it's
to
total
keep-
pressure, man. So we don't have to subtract.
So we're gonna have to add it eventually.
You'll need it eventually,
But just not now.
not at the start. Because listen, at the start of this reaction, there isn't even water, period. What are your two reactants?
Oxygen and methane.
Do either one of those say water? No. So at the start of the reaction, you don't need to worry about it. This is a limiting reactant question. Now, are they the same moles?
I think CH4 is 1 mole and O2 is 2. Oh wait, not moles. That's the half of the reactant. But I'm pretty sure they have the same amount.
If I take 5 divided by 32, you might be right. Let me look. I do this occasionally on complete random chance. I'll come back. Let's see. So we have the both same amount of moles. That's what you're telling me, Soraya? So there is no limiting reactant? Okay. Say that again.
Now oxygen isn't twice as big as.
In grams.
When you balance it, there's supposed to be
No, oxygen has to be twice as big.
Yeah.
But it's 0.15, right? It has to be twice as big as 0.312. No, that's not. You don't look for if CH4 is twice as big.
What?
It's the number before that says.
Yep.
or not.
Okay, and that would be the pressure before.
So if you have two
Yep.
parts of oxygen and they're 0.15, and then you have 1 part of methane and it's 0.3, is oxygen 2 times as big as 0.3? No, it's half of it, so it's the limiting reactant.
Isn't this one just 1, 2, 1, 2 or 2, 4, 2, 4?
She stopped listening to me.
She could.
Like Misha sometimes.
Oh.
Okay.
Does anyone, what's the total number of moles at the start? Anyone have this answer right here? 0.468?
Yeah.
Okay, good enough. I didn't have space, so I just put R right there.
Oh, I did have that. Never mind.
We just divide by 4.
Yeah, oh my is right. It's not as terrible as you think. You just don't know how to do it yet. Yeah? No. Mass of the what?
Is the unknown.
Yeah, but what pressure are you going to use?
Pressure
is gonna be 760 minus 230,
No,
23.7.
no,
It's not?
no.
Dang it.
I love you though. You're close. Okay.
Oh, no. Is
Part-
the question you got from 3?
Nope. 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 Okay. Part B, we just solved for the total moles of oxygen and methane, add them together, and then pivnerd it. What did we get?
2.86.
Yeah.
Okay, 2.86. Okay, part C can be super tricky or not really that bad. We need mass of water. So I'm going to do all this math and I'm going to multiply it by 18. Why am I going to multiply it by 18? Because that's the molar mass of water. All right, then I'm going to use pivnerd to solve for N. Just trust me for a second. And then, oh, you can't trust me for a second. Grace, we use this as our pressure. Because this is the pressure of just water. I don't know. I can tell you if you set it up right. You solve for N and then multiply by 18. It should be a small number.
I got 0.09 grams.
Yeah,
Why
that sounds
would you-
smart.
Because that's the molar mass of water.
So you always multiply by 18.
Well, you just have to get it back to grams.
I'm only gonna move it.
Oh, yeah. So, but like this
It
is
looks set up
that's
right.
You're solving
Okay,
for N.